Modern nuclear weapons work by combining chemical explosives, nuclear fission, and nuclear fusion. The explosives compress nuclear material, causing fission. The fission releases massive amounts of energy in the form of X-rays, which create the high temperature and pressure needed to ignite fusion. So in this video, we are going to discuss how nuclear bomb works. The video is going to be amazing. Make sure to stick till the end. Before starting the video, be sure to smash the like button and subscribe to never miss out on any of our videos. At the center of every atom is a nucleus. Breaking that nucleus apart or combining two nuclei together can release large amounts of energy. Nuclear weapons use that energy to create an explosion. Fission and fusion. All matter is composed of atoms, incredibly small structures that house different combinations of three particles, known as protons, neutrons, and electrons. At the center of each atom is a nucleus, where neutrons and protons are bound in close proximity together. Most nuclei are relatively stable, meaning the makeup of their neutrons and protons is comparatively static and unchanging. During fission, the nuclei of certain heavy atoms split into smaller, lighter nuclei, releasing excess energy in the process. This can sometimes occur spontaneously, but can also, in certain nuclei, be induced from outside. A neutron is shot at the nucleus and is absorbed, causing instability and fission. In some elements, such as certain isotopes of uranium and plutonium, the fission process also releases excess neutrons, which can trigger a chain reaction if they're absorbed by nearby atoms. Fusion works in reverse. When exposed to extremely high temperatures and pressures, some lightweight nuclei can fuse together to form heavier nuclei, releasing energy in the process. In modern nuclear weapons, which use both fission and fusion, a single warhead can release more explosive energy in a fraction of a second than all of the weapons used during World War II combined, including Fat Man and Little Boy, the two atom bombs dropped on Japan. How nuclear work. All nuclear weapons use fission to generate an explosion. Little Boy, the first nuclear weapon ever used during wartime, worked by shooting a hollow uranium-235 cylinder at a target plug of the same material. Nuclear fuel. Only certain isotopes of certain elements can undergo fission. Plutonium-239 and uranium-235 are the most common isotopes used in nuclear weapons. Each piece by itself was not enough to constitute a critical mass, but by colliding the pieces, critical mass was reached and a fission chain reaction occurred. Modern nuclear weapons work slightly differently. Critical mass depends on the density of the material. As the density increases, the critical mass decreases. Instead of colliding two subcritical pieces of nuclear fuel, modern weapons detonate chemical explosives around a subcritical sphere of uranium-235 or plutonium-239 metal. Once dense enough to reach the critical mass, neutrons are injected, initiating a fission chain reaction and producing an atomic explosion. In fusion weapons, the energy from an initial fission explosion is used to fuse hydrogen isotopes together. Warheads in depth. The explosions used in thermonuclear weapons are often described as a primary, the chemical and fission explosions, and secondary, the subsequent fusion blast. However, the actual mechanisms are considerably more complicated. For example, a pure fission primary is inefficient. The plutonium pit will blow itself apart before most of the plutonium-239 can fission. Instead, the reaction can be boosted by including hydrogen gas in the center of a hollow pit. As the surrounding plutonium fissions, the hydrogen gas undergoes fusion and releases neutrons, inducing additional fission. Similarly, the secondary doesn't consist purely of fusion fuel. Layered within it is a fission spark plug, consisting of either plutonium-239 or uranium-235. As the primary explosion compresses the fuel from the outside, the spark plug material becomes supercritical and fissions, heating the hydrogen from the inside and facilitating further fusion reactions. Fusion releases neutrons. These neutrons hit a layer of uranium surrounding the fusion fuel, causing atoms in it to fission. This fissioning generally contributes more than half of the weapon's total explosive yield. Thermonuclear weapons that don't include this uranium blanket are called neutron bombs, as the neutrons freed by fusion are released from the weapon. Neutron bombs therefore create a larger amount of radiation than a normal weapon of the same yield. During the Cold War, such weapons were considered for use against tank attacks, with the goal of disabling tank crews without having to physically destroy the tank. Who has nuclear weapons? The United States was the first country to develop nuclear weapons, detonating the first fission device in 1945. 7 years later, the United States successfully tested the first hydrogen bomb during Operation Ivy. As of 2018, the United States had an estimated 6,500 nuclear warheads, including retired, stored, and deployed weapons. France, 300 warheads, China, 260, the United Kingdom, 215, Pakistan, 130, and India, 120, also have nuclear weapons. Israel has not officially acknowledged its nuclear capabilities. Estimates of its arsenal have typically been around 80 warheads, although some estimates are significantly larger. North Korea's capabilities are largely unknown. It's suspected it may have a limited arsenal of 5 to 10 weapons, but may have material to build twice that many. At the peak of the Cold War in the mid-1980s, the world had a combined total of over 60,000 nuclear warheads. Today, that number is closer to 15,000, representing a 75% reduction. This progress was made possible thanks to leaders and advocates who recognized the very real dangers of nuclear war. Let us know your opinion in the comments section below. This was all for today. Hope you liked the video. Subscribe to our channel and stay tuned for more interesting videos. Stay safe, and we will be back soon with another video.